Okay, so today what we're going to do is we're going to talk about making predictions based on the model. And the model we're talking about is that line of best fit, that little blue dotted line that the computer is going to draw for you when you ask for it. So we can use a model to make a prediction based on the information that we have so far. Okay? So we're going to walk through how to do that, and then we're going to talk about the two different types of predictions that you can make, as well as how you're going to write about that information in your report. Right? So pay close attention to the formats that we've been using about writing these. That's the kind of things that are going to be really important to you when you do your data. Okay? So, using the model to make a prediction, there are two different types of predictions that you can make. And you need to know which one is which. If you make a prediction without telling which one it is, then you're not showing much statistical knowledge, so it's not going to get you very far. Making a prediction is going to be part of it, but you're going to have to make sure that you know what prediction you're going to be. And there are two of them. Right? And the first one is called interpolation. Interpolation is when you're using a prediction within the range of data. So think about within the range of the data. But if you think of the word inter, right, it's interspersed within the data that you already have. Okay? Does that make sense? So what you're going to do is you're going to be looking for a point that they may or may not have given you as one of your data points. Usually it's some other point. So if this other stuff is true, how about if the boat was 12 feet long or 15 feet long or the fish weighed 20 kilos, right? So you're just going to use the data. Now, there are two ways you can do this. You can do this by simply looking at the graph and reading from the graph, right? So in this case, a 70 centimeter fish, they want to know about how much that would weigh. So all you're going to do is go to 70 centimeters, which is right there. Go up until you hit the line, and then go across, and that means that a 70 centimeter fish should weigh about 5 kilos. Okay? So you can read it from the graph. But many times the graph doesn't land so easily so that you can read it accurately. So when you do that, you're just getting a close estimate. The second way you can do it is by simply putting the given value into the equation. Because remember, every one of these is always going to have an equation given. And this is your x, this is your y, right? So if y equals, you're just going to simply replace the number they give you in place of the x, and then just do the math. And that's why I said using your calculator is a lot easier. Yeah? But you can certainly do this by hand if you have to. But the numbers are going to be tiny, so calculator's much better. Now, notice that they've rounded their answer, and the way you round is always going to be determined by the strength of the relationship. And that's determined by the correlation coefficient, right? Okay? So if it's closer to 1, that means a very strong relationship, yes? Which means that you can round, that you can leave more decimal points. In other words, you're more certain that this is an accurate picture of what's happening. So you can use a much more definite number. Now, but if the relationship is very weak, you wouldn't round to a lot of decimal places. You just use whole numbers. Okay? Because it's just a guess. It's anybody's guess. Because if there's not a strong relationship, tying it to the equation may or may not be true. Right? And we're going to look at several examples in how you can tell how you can tell which one to use. Okay? So interpolation means what? Where?
A prediction made within.
Yes, exactly. A prediction that's made within the data. Okay? The other one is called extrapolation. Extra. That means outside the data. Okay? So let's look at that definition. It's the second one. So there's that word, so you can spell it. So an extrapolation is a prediction made beyond the range of the data. So in other words, you're outside of your dots. It's an extra piece of information. So here, you see that they're using this blue dot. Here's where your data dots all stop there at 9. They want to know what's happening at 10. So extra means beyond what you've already done. All right? Beyond the data. So if I was looking for this particular point, would that be interpolation or extrapolation? Interpolation, right? Yeah, probably don't say it the same way y'all do, but yeah. All right. But if it's outside of your data, then it's extrapolation. Extra, right? Means outside. And the same thing can happen. You can find it using the graph. So here I can just read up to from 10, go across, and get a value, right? But that's not a very accurate value, but you can certainly use it. Or I can simply put the number they give me in place of the x in the equation and work and do the math. And that gives me a much more accurate picture. Now, if you look at this, what do you notice about these dots, the black dots? Are they tight together? No, they're all spread out. They're everywhere. They're all over the place. So is this a weak relationship or a strong relationship? It's very weak. And so you'll notice they just rounded it to the nearest whole number. If it's a very weak relationship, I wouldn't even bother with the equation most of the time because I don't know if that's really what's exactly happening anyway, right? But if it's a very strong relationship, you must always use the equation because you want as accurate a number as you can possibly get. See the difference? For a strong relationship, you can get a very accurate number. For a weak one, you have to use you can't assume a very accurate number. Okay? So we're going to look at some of these. I'm going to make it bigger, guys. We're going to look at some of these so that we can practice how you can tell, and also so that we can talk about how you're going to use this data. Okay? Okay? So let's just look at a couple of these. So here we go. We're going using interpolation here, which means that the data they want is within the data range we already have. Estimate the mass of a 70 centimeter fish. So a couple of ways to do it. You can do it from the graph. Here's 70 centimeters. Simply go up from that point until you hit the line. You hit it right there where they've drawn the blue dot. Go across, and it says that a 70 centimeter fish should weigh about, not exactly, but about 5 kgs. Okay? Now, alternately, you can put the 70 in place of the x in the equation, and remember the equation is always going to be there. And here also they give you not r, but r squared, so you could find the correlation coefficient and decide how strong the relationship is there. Okay? And, excuse me, you just put that 70 in there and then do the math. It gives you this. They rounded it to 1 decimal place because everything else in the data set was rounded to 1 decimal place. And we rounded to 1 decimal place because this is pretty strong, right? Those dots are very close together, and if you did this, you would get a correlation coefficient very close to 1. So it's very strong, so they rounded it just like everything else in your data set was rounded, which was 1 decimal place. If it had been very weak, then you probably would just rounded it to 5. Okay? Because you don't want to be as accurate if the relationship is not as weak. Now let's talk about the observations, or in other words, how you're going to put it. So first of all, calculate and estimate. Okay? Which one do you think is which? Equation or graph? Calculate or...
Estimate would be graph. Calculate would be equation.
Yeah, there you go. Calculate means use the equation, because calculate means do the math. This one is an estimate. So you're going to estimate using the graph. Right? Because you can't exactly be sure where that line is hitting and get an exact value. But if you calculate it, that's an exact value, right? So you're going to have to do both. Okay? So the observations. We need to know, for our rounding, that the relationship is very strong or not, right? And our second observation is we are estimating within the range of data. So estimating within the range of data tells you that this is what kind of Estimation? Interpolation, or however y'all say it. Okay? Now, as a result, what do you expect about the estimate then? If it's fairly reasonably accurate. Okay? All right, and again, we're going to see lots of these. Now, this one, they're just giving you a few little pieces. The next one, they're going to show you, as we build, they're going to do it a little more. So here we go. Estimate the time taken to complete the puzzle by a 6-year-old. Okay, and they want the time for a 6-year-old. Well, on the bottom is ages. Here's a 6-year-old. So just go up till you hit the line, across. It tells you about 11 minutes. Is that calculate or estimate? Estimate. Good. Then here, they plugged the 6 in and did the math. Still got 11 minutes. Calculate or estimate? Calculate. That one was calculate. Good. Notice the dots are all over the place, right? So what does that tell you about the strength of the relationship? It's weak, so they went ahead and rounded to the nearest minute. Don't put a decimal because you don't have any idea, right? So just round to the nearest whole number if it's a weak relationship. Okay, because you're just giving an estimate. Oops, sorry. Okay, so let's look at our observations. Again, our data point was within our other data, so that is an interpolation. Good. The relationship is strong or weak? Weak. So we are estimating within the range of data. That makes it an interpolation. And as a result, although we're estimating within the range of data, the relationship is weak, so we could not have great confidence in this prediction, right? Because that line is not a very good predictor about where the dots are going to fall, right? Because most of them don't fall anywhere near the line. So they're all over the place. Okay? So get used to these sentences, the way they write it. So you're just going to have weak or strong, potentially somewhat weak. All right. The next one is extrapolation. That means I'm working with data that is where? Beyond the data points, right? So look at this one. For a 10-year-old, here's age 10. Gives you the blue dot. But again, that is outside the range of all the black dots, isn't it? It's beyond the black dots. So that's extrapolation. What do you notice about the relationship? It's weak. They're all over the place, right? And you could certainly find the correlation coefficient to tell you how weak. Okay? So going across, we see that 7 minutes, and we're just going to leave it as 7 minutes because we don't need decimals, right? Because it's such a weak relationship that's just a guess anyway. It's anybody's guess.
So
okay?
If it's a weak relationship, you don't have to calculate it.
Well, this book, they're going to ask you to estimate and calculate. So yes, you still have to do it, but just for practice. It really doesn't make any difference to your answer because it is a weak relationship, but you will have to do both. Mm-hmm.
Do you know if it's extrapolation, like, can the blue dot be in the middle of all the black dots, just not on a specific black dot, or is that still?
No, it's still interpolation. If it falls within, so in this case, if it falls within 3 to 9, that's interpolation.
Okay.
If it's before or after, and it's going to have to be after because nobody's going to do it faster. You could be given a 1-year-old, I guess, but that's really outside of your data set. Usually it's going to be beyond. Extrapolation almost exclusively means in the future. Okay? All right. You're estimating beyond the range of data, so we have assumed the linear model continues beyond the edge of 9, but it may not be the case. Ooh. That is what's called statistical insight. And that is what you need to get an excellence. Now, again, remember, we're going to have a template for you, but when you're writing these out, you need to write something like that if you're expecting to get excellence. Yes? Now, if it's time, does time always go beyond? Yes. But if you're talking about subjects in a study, does it mean there was a 20-year-old in your study? Maybe not. So you need to make sure that you recognize that fact. So, in other words, all the children in this study could have been only up to 9 years old. There may not have been a 10-year-old. But if there was, then this is what our data would tell us. Okay? So make sure you're careful when you're dealing with extrapolation. You're pushing things into the future that might not exist. Okay? The future can change. All right. As a result, we would not expect this estimate to be very accurate. Right? In other words, it may not even exist at all. So it can't be very accurate if it may not even exist. Okay? One more. And here we go. This one, they finally get to almost everything that you're going to have to do. We'll do one of those others together too. Estimate the mass of a 100 centimeter fish. Notice that 100 is right here. What do you notice about it? It's beyond our data points, our black points, yeah? So that means that this is an extrapolation. Very good. Yeah, extra. So just plotting it on the graph, we go up to there and across to there, we get 9. Okay? And that is an estimate based on the graph. And it's the best you can do with the graph is get an estimate because you can't read that exactly. Now over here, they plugged 100 into the equation and actually did the work. So that's not estimation, that is calculating. Good. And they got it to 9.2 kilos, and they're going to leave it as a decimal. Why would they leave it as a decimal? The relationship is pretty strong in this one, right? Which means that we can be fairly confident that that number is going to hold true. Yeah? Good job. Okay, so let's talk about what we have. The relationship is weak or strong? Yeah, in this case, very strong. Again, the only way you're going to know which descriptor to use is to calculate the correlation coefficient. Now, again, in Grapher, it's going to do that for you, but for this book, for some reason, you're always going to have to take the square root of it. Okay? So to know which words to use, you need that number. Get in the habit of doing it. You're estimating well beyond the range of the data, so we have assumed that the linear model continues beyond a fish length of 88 centimeters. However, this may not be the case. Every extrapolation should always include that bit. We are assuming or have assumed, right? What is it you've assumed? And you need to know and state that that may not be the case. Particularly as there's very little data for fish that are longer. So if you look up here, it's almost blank, isn't it? So there's really not much to go by. Okay? All right. Although the relationship is very strong, we cannot have a great confidence in this prediction. A prediction of 90 centimeters will probably be more reliable because it's closer to the data. Now, the relationship is very strong, but we still are worried. And that's always going to be the case when you're extrapolating, right? When you're extrapolating, you can never say the relationship is very strong, so I'm very confident in my results, right? You're always pushing beyond the boundaries. So you need to make sure that you explain that you know that that's what's happening, right? So use their sentences as a model, and if you want full credit, you'll use numbers and their units. Okay? All right. Let's look at another one. Oh, well, that's the second one. Okay? All right. And extrapolating way beyond the data, just don't do it. All right? If it's 10, 20 units beyond what you're working with, just say extrapolation would not be feasible in this case because that would require me to extend the data for way further than, right? So in other words, so if they wanted like 110, don't do it. Because 110 is not even on your original graph. So there's a reason somebody created this graph to be that size, right? Remember when we created our graph, we paid attention to what size they were. Mm-hmm. You would still explain it, but you don't have to. I mean, if it's a workbook exercise where they're going to ask you for these values, then give them the values. But if you were, yeah, we're not going to ask you for that. But if someone asked you to extrapolate like that, just tell them it doesn't make any sense to, right? Okay. Now in these models, of course, you're going to be filling in the blank. So if there's a blank, you need to put something. Okay. So let's just look at this one. Estimate the height of a year 13 student with a 1.9 meter arm span. Is this interpolation or extrapolation for 1.9 meters? Yeah, 1.9 is 190. Okay, I don't know why they changed units, but that's no big deal. So that's right here, and that is not in your data set, is it? So that's extrapolation. Good. Good or bad? It's always iffy on this one, and it's not the one we like to do because we have to explain that it's iffy. Okay? Estimate of the height, well, if you continue that line out, it looks like about 190 centimeters, maybe. Best we can do. So this time we had to stretch our blue line out to meet what our other one is, so that's not good. So about 190 centimeters. Calculate the height. So to calculate it, all I'm going to do is in place of the x, I'm going to put 190 and then do the math. Yep. So what you're going to do is you'll do 0.961 bracket. You can put y equals if you want to. Okay. What is that?
Why do you do 961 like that?
Because that's coming straight from the equation. Yeah. So what I'm doing is I'm just putting a number in place of the x, and I'm going to do the math. So if you replace a letter with a number, you always put it in a bracket. And then just write in everything else. What is that? 7.8656. And then you're just going to do the math. We always do brackets first, so we'll do that part first. So somebody with a calculator want to tell me what 0.961 times 190 is? Anybody with a calculator? Come on, guys.
190.569.
When you multiply those, multiply them. Right? Because the bracket needs to multiply. There you go. Just these two numbers. Oh, you did the whole thing. Okay. Yeah. 182.74. Plus, and you're going to add in the rest of it. And that's going to give you about what? 190. 56 something. Okay. All right. So if we did add that one, we'd round it to about 190.6. Okay. Now, again, you would have data, and if they rounded to one decimal place, two decimal places, or whatever, then they would tell you. So with the calculation, is this relationship very strong or no? Yes. So I could keep my decimal as long as my other values had decimals. If they were all rounded to whole numbers, then you'd round it to a whole number as well, right? But in this case, we're pretty certain, right? Don't forget your units.
How did you get the 182.74? Where is that from?
It's just that times that.
Times just this
0.961 times 190.
and then you plus this in it.
And then add that in to get your total final answer, right? Just using order of operations. You do the multiplication first and then add them in. Okay? The relationship is what? Strong. Okay? We are estimating within or beyond the data? Beyond, right? Be careful. We're beyond the data, so extrapolation. So that they're asking the same question twice. As a result, because we are estimating beyond the data, even though the relationship is strong, now you can read this out of the back of the book, and it's going to be slightly different from what I say. Even though the relationship is strong, that data point may not exist in reality, right? Because the largest fish in our study is 180. I could assume that 190 is a reasonable answer. Why? It's a strong relationship, and 190 is not that far from, well, that literally looks like about 182 or something. Really not that strong from my last data point. Is it?
Can you repeat?
Yeah. Well, let's use theirs from the back of the book. We'll go to the back of the book and look at what they say. But I'm just kind of talking you through it, right? Can I say that it's absolutely going to be that value? No way. I can assume it is because the relationship is strong, and 190 is really not that far from my last data point of 182. However, a fish that, or whatever, this is a height. A student who is a year 13 student, there may be no year 13 students who are 190 centimeters tall, but that's really not outside. Really, I'd probably say it is. We could assume that some year 13 student could be 190 centimeters tall, yeah? That's tall, but that's not out of the range of tall, is it? Okay? So you just, what you know, right? If a year 13 students, all right, now if this was year 7 students, would 190 be improbable? Yes. But year 13 students, it could happen. So just say what you could. So let's just go to the back of the book. Somebody want to read me the back of the book? What is this page? This is number 2 on page 35. Any volunteer to read me what they say about as a result? And you all have this, so. Yes? No? Somebody? Find it yet? Page 35, number 2. What'd they write? There you go. Go ahead.
This means that we are assuming that the linear relationship continues beyond the range of data. This may not be the case. There are only 2 people who are over 180 centimeters tall, so we cannot be confident that the model continues to be valid beyond 180 centimeters. However, we are not exploiting far from the end of the data.
Right. Again, that's what I was saying is it really isn't that far from the last pieces of data, but those pieces are actually pretty far beyond the other pieces of data. So just explain it the best you can. Now, if you don't use exactly the same terminology they use, it's fine, right? The more detailed you can get, the better, yes? But don't get so carried away that you end up explaining away your answer. And that's always the habit, the hard thing about writing too much. Most students who write too much, what they do is they end up saying exactly what they mean and then explain it away and say something that's not true, right? Based on the data. So be careful. I would rather you write something that is almost there, right, than something that leads you into dangerous territory, yeah? So you'll be writing several of these, so you'll get lots of practice. Try to write something down, then check your answer in the back. But if you're totally stumped, just look at the answer in the back and then write something based on that. Don't just rewrite what they wrote in the back. Try to say it in your own words as close as possible, and then go back and add to it if you need to once you've checked your answer. Okay? So what we're going to do is we're going to do these problems. They run from page 35 to 38. All right? Lots of room in there. So page 35 to 38. You can work on this now, please.